is it going to be a minimum? So I can do a second derivative. Okay, so earlier this is my dm over dx, right? Now we want to verify it. Okay? Can you erase this part? I got to erase all this. Okay, so we find that the second derivative is more than 0. Okay, and then after that, since it's more than 0, it will be a minimum. A minimum value. It's a minimum value. Yes, yes.
So find coordinate of P such that that P will have a gradient that's either maximum. So this coordinate of P, is it for the normal or is it the intersection between the curve?
The normal will be for the curve, but so the intersection between the normal and the curve and also the tangent, it will all be on the curve itself. Isn't it? This normal is for the curve, right? So the point P will have to be on the curve as well as on the normal, as well as of course on the respective tangent. Yeah, of course. Because this normal is related to the curve, but the normal is not some other line that's away from the curve. It doesn't make sense that the normal is detached from the curve, right? You understand?
substitute the 2 and 1
This one, for what? It will be equal to 0. You substitute 2 negative 21, it will be equal to 0. Because you got 2 from this, it will be equal to 0.
the negative 1 basically an m.
Substitute into that. For what? But you find a gradient value. You want to find a gradient value for what? We don't want to find a gradient value. We want to find the coordinates of the curve itself. Yes, okay. Why am I allowed to make this claim? Oh, but we verify one, that's why I verify one. Okay, because the question says maximum or minimum so surely it should be giving to you a maximum or minimum. It doesn't make sense that after it equals to 0 then this is going point of inflection. That means something is not right already. You understand?
Then all those not proving questions when they ask you that this thing doesn't discriminate against the same and that thing is
The question is phrased differently, you know. Yeah, that kind of question is phrased differently. Yeah.
The exam will come out like 3, 4, 5 they ask.
No lah, it will be manageable for your standard of algebraic learning. Alright. Maybe let me just go through what am I doing over here. Okay. So do we all agree that we have to find dm over dx so far? Anybody still don't understand why I need to find dm over dx? Okay, finding dm over dx, it is solely for us to equate it to 0 so that we can find the maximum or minimum of the gradient, okay, of the normal. Right, the objective, the subject that we're looking at now, it is the gradient of the normal. For that to be the maximum or minimum. We are not trying to find the curve's maximum or minimum. So then we equate that equals to 0, okay, because the maximum or minimum will give us the first derivative of that to be equals to 0. So now we need to change our language, okay, rather than focusing that first derivative is always gradient, okay, then after second derivative means what? You never ask me that, you know. Okay, so second derivative, yes, it is actually, if you want to put it into context, it is the gradient of the gradient, but that doesn't really make much logical sense. Okay, so that's why the words that we use, we should maybe look at always be using first derivative and second derivative. Okay, the application of gradient itself, it is to the context of the question. So now the subject itself, it is the gradient of the normal, differentiate that first derivative equals to 0. Then we find this value x equals to 2. Okay, but we go back to the question itself. What does the question want? The question wants you to find the coordinates of point P. The point P will actually lie on this curve. It will also lie on the normal itself, the normal line. But the thing is that we do not have the equation of the normal line. We only have the equation for the gradient of the normal, which is the one that was expressed m equals to something. Okay, the one m equals to negative 1 6x squared minus 24x plus 1. Okay, this is the equation for the gradient, but it's not an equation for the normal. You understand? This is equation of gradient, not equation of normal. Okay, gradient of normal lah, okay? Alright, so that's why I need to substitute x equals to 2 back into the equation of the curve. Okay, because that is where the point will actually lie. It will lie on the curve. Alright, so the point on the curve, okay, will give us the y coordinate negative 21. So now we will be able to find that 2 negative 21 will give us such that the gradient of the normal is maximum or minimum. You understand what I'm saying? Okay. In case it is going to be point of inflection, because the question tells you that, you know, we are trying to find something that is maximum or minimum, surely it should give you maximum or minimum. Okay, it should not be giving you point of inflection after you do the second derivative test. Alright, if it gives you a point of inflection from the first derivative test, in fact, okay, because second derivative you cannot find point of inflection. Okay, so if you do first derivative test, right, and it gives you point of inflection, that means surely somewhere over here you have done it wrongly already. Your understanding is must have been wrong somewhere. Okay, or your calculations must have been wrong. Okay, that's why when I do my second derivative test, I substitute in the value x equals to 2 inside it. I get that it is going to be 12 over 529, that is more than 0. So therefore, I can prove that by second derivative test, okay, this point will give me such that the gradient of the normal is going to be a minimum. You understand what I'm saying? Okay? Any questions? Okay, so we agree now we need to change a bit of our lingo. Don't always be using the m over dx, dy over dx to be equals to gradient. Okay, it may not always be the case. Yeah.
Do you need to put like since dy over dm over dx equals to 0, then d2?
Yeah, best to put that lah. Right? We have I'll put it up. Since at we have put it here at since dm over dx equals to 0 and d2m over dx squared more than 0. Okay. Alright. Any questions? Can we move on? Okay. Okay, let's go to this question. Right, we're given a prism, okay, and then after the cross section of it is an isosceles triangle. Okay, so AC is 5 cm, AB is 5x cm. Okay, so BC is 6x cm, and then after that the height of the prism is h cm. Okay, and then also given in the question, the volume of this prism is 4,500 cm cubed. And in part 1, we want to write an expression for h in terms of x. Okay, I erase this already. Okay, so how do we find this expression?
Volume divided by the base area.
Okay, so what's the base area? What's the base area?
Half times.
Why look at my face? Look at the diagram, right? What is the base area? What's the shape? The triangle. How do you find the area of the triangle? Half times 4 times 2?
4 times 6.
4 times 6? What 4?
How do you get 4?
Pythagoras theorem 5.
We have to do Pythagoras, okay? Because we need to find the height, right? Half times base times height. So we need to find out what is this height of the triangle. Okay, so this is isosceles. This means that down here will be 3x. This will have to be 3x, right? Okay, so therefore, height of triangle Please do not use h. H is already used somewhere else. Okay, so that will be equals to 5x squared minus away 3x squared. Alright, so that will give you 4x. Alright, please can't see it. 25x squared minus 9x squared equals to 16x squared. That will be 4x.
So, like, if you know that the answer is 4, can you just write 4?
No lah, how you get 4? Tell me, you need to put in explicit
Like,
workings.
by negative.
No, since when do you ever learn that? Since when have I ever done that? No. Okay, so the volume of the prism okay, that will be half times base times height times 6x times height 4x times h, right? So 12xh, that is the volume of the prism, and that is going to give you 4,500. Oh, so x squared is. Okay. Then we want h in terms of x, alright? So we do some manipulations. So therefore h is equals to 375 over m squared. Okay. Then in part 2 we want to show that the total surface area is given by a certain equation. Write that down. Okay, so we want to show this total surface area.